Hi and a very good day to Dr. Hadawati. We are from group number 6, going to present about the assignment 1, which is intrinsic and distortion coefficient parameter determination from smartphone. So first, let me introduce myself. My name is Chong Shin Lin, matrix number CE190028. So I will also introduce my other group member. The second group member is Nur Aini Nadira binti Kamarul Arifin, matrix number CE10000449. The last group member is Yvonne Yi Sisan, matrix number DE190014. So this is the introduction for this assignment. Camera parameter are the parameter used in camera model to describe the mathematical relationship between the 3D coordinate of a point in the scene of which the light comes from the 2D coordinate of its projection into the image plane. The intrinsic parameter, known as internal parameter, the parameter intrinsic to the camera itself, such as the focal length and lens distortion. The extrinsic parameter as an external parameter or camera pose parameter used to describe the transformation between the camera and its external world. The objective of this assignment 1 is investigate and solve vision system problem using technique and concept of vision system engineering. The second one is analyze vision system problem using a technique and concept of vision system engineering. The third one is organize a group teamwork to construct a complete vision system module for a certain application related to mechatronic system. The last objective is demonstrate the importance of vision system in current technology trend for sustainable development. So this is my Huawei P40 Pro model for doing this assignment 1. So I will briefly explain the camera specification for my phone. So this phone, Huawei P40 Pro, has a 15 megapixel ultra vision camera, which you can see here. It has a 1/1.28 inch ultra vision sensor, RYYB color filter array, Okta PD autofocus, take in massive light and detail for super clarity. And it also has 12 megapixel telephoto camera. We have the optical zoom, hybrid zoom, maximum zoom, and meet the unseen detail. So next one, this phone also have 40 megapixel ultra wide cine camera, have a 1/1.454 inch sensor, ultra low light video, ultra slow motion video, telephoto video, 4K time-lapse video, and then cinematic video camera with multiple features. And then lastly, it has the 3D depth sensing camera, real-time depth detection, and create a professional level 4K effect. So now I'm going to demonstrate the step of doing this assignment 1. So first, we open the MATLAB software and then go to apps. Then we search for the camera calibrator and then wait a moment. So the camera calibrator will pop up a new windows. After that, we go to add image here. Then go to the photo files. So these 10 photos, 10 image, I was taking using my Huawei P40 Pro. Then we select all and open, click open. And then it will pop up these windows. Then we click OK. So as you can see here, the left side here, to begin, we have to add image, at least 10 to 20 image. So for this assignment, we only took 10 image for this assignment. After we open and select the image, then we have to wait another moment for analyzing image. Now the photos, the image here is all loaded in our camera calibrator here. So it will appear this. So we can go to the option here to click for 3 coefficient. Then tick for the tangential distortion. As you can see at here, it will appear a white box with the right top here. The green color here, the green one is the detected point. Then the yellow one is the checkerboard origin. After that, we can click for the button for calibrate. So before this, I click for 3 coefficient, means that here will appear another one. The red color one is for the reprojected point here on each image. So after we click the calibrate, it will appear this reprojection error, and then the vector centric and the camera centric. This is the reprojection error. And then this is the vector centric. Then another one is the camera centric. So now we have to click the export camera parameter here, and then click for the general MATLAB script. Then we have to wait for a while. Then so this is the script that we generate from the previous file. So we have to save first. After we set, we can click run. Then we have to wait for a while also lah. After we click run, then the common windows here will appear this, the standard error of estimate.
Assalamualaikum and hi, my name is Nur Aina binti Kamal Arifin. My matric number is CE1009. So for this group assignment, I will continue the methodology part. First is that we start, then we apply camera calibration in the MATLAB software. Then we extract grid corner of the image. Then we calibrate the image. We show the extrinsic result. The extrinsic result for the image, the camera center or the work center. Then we analyze image and distort image and the end. So for my part, is I will use iPhone 6s, which the camera consists of 12 megapixel camera, live photos with stabilization, autofocus with focus pixel, optical image stabilization is for the iPhone 6s Plus only. Then the True Tone Flash, panorama up to 63 megapixels, and auto HDR for photos, exposure control. It has 2 modes, which are burst and timer, and its aperture is 2.2, 5-element lens, and 5 times digital zoom. Also consists of hybrid IR filter, backside illumination sensor, and the sapphire crystal lens cover, auto image stabilization, local tone mapping, and has noise reduction, and the face detection, which will autofocus our face, then the photo geotagging. So next, I will move to the demonstration. So for the demonstration, we open the MATLAB software, and we choose apps. We go to camera calibrator. Wait for a while. It takes a while. And it will pop up this camera calibrator. So next, we add the image. For this image, we need 10 meters of image. This is the image that I take. needs to be in the same size, which if you take the image in horizontal, it means all the 10 images need to be in horizontal size. So this is pop-up image and pattern properties. Checkerboard, size of checkerboard is 75 millimeter. And click OK. Okay. So here it is the 10 pictures that I take. So next for the options, we choose 3 coefficients and tangential distortion. Then we calibrate. So this is for the checkerboard, and this is the camera centric, and this is for the pattern centric for the reprojection error. Okay. So here, camera centric for the focal length. What do you call it? For the focal length output, we need to export the camera parameters, generate MATLAB script. This is the image that we include in the camera calibration, and we click run. So it will pop up the extrinsic parameters visualization and mean reprojection error per image. So first, for the extrinsic parameters, there is 10 Planck, which it is for our image, represent our image. Next is for the mean reprojection error per image. So for the image one, there is 4 1 something is 3. Next is the focal length. The intrinsic focal length pixels is 1182.6821. The principal point pixels 582.7800. The radial distortion is 0.4871 and the tangential distortion is negative 0.0302. So for the extrinsic, its rotation vectors negative 0.0307, 0.0341, negative 0.2121. This is all the rotation vectors, and this is the translation vectors in millimeters. This is negative 71.1323. All of these are represent our 10 images. So I guess that's all from me. Thank you.
Good day to my lecturer and my fellow friends. My name is Yvonne Izusan. Today, I will going to explain about the distortion and the intrinsic parameter using my phone. I'm using iPhone 12 Pro Max. It consists of 4 cameras. With the one is the front camera and the 3 is at the behind. It got the Pro 12 megapixels camera system with the ultra wide and telephoto cameras. With the ultra wide camera, it consists of 2.4 aperture and 120-degree field of view. Wide camera with the 1.6 aperture. Telephoto camera with the 2.2 aperture. It can get the 2.5 optical zoom in, 2 optical zoom in, and also 5 optical zoom lens. It can also digital zoom out to 12. The night mode portrait enabled by the LiDAR camera. It got the portrait mode, dual optical image stabilization. It also using panorama. It has the sapphire crystal lens cover. Night mode, deep fusion, smart HDR 3, Apple ProRAW, white color capture for photos and live photos. Lens collection, advanced red eye collection, photo geotaging, auto image stabilizing, brush smooth, and also the image format capture is HEIF and also JPEG. Next, I will explain about how to do the simulation using MATLAB. This is the image I captured using my phone with the 10 different degrees, 10 different angles. Now, open the MATLAB, choose the apps. I need to use the camera calibrator. To begin, we need to add image. So I add the image that I capture using my phone. Then select the size of the checkerbox square. We're using 25mm. Okay. Now, MATLAB are detecting the checkerbox in the image. Now, the image has been imported into the camera calibrator app. So, we calibrate. After carry back in, it will come out the extrinsic image. This is the camera centric pattern, and this is the pattern centric pattern. We got two patterns. Then it will also analyze the error. After that, we need to save this project. Then after this, we need to save our work. Then we'll save it using the M format. Okay, and save it here. After that, we need to save the work. So, the topic is elevation assignment. After the elevation, we need to set the code. So, after enter this, need to open and run it. After we run it, it will come out the intrinsic, the focal length, principal point, and this is the extrinsic parameter visualization, and this is the analysis error. So this is my result from MATLAB. This is the extrinsic parameter, analyze error, and the exact grid corner. Next is, this is the result for intrinsic and reflection. The focal length slightly increased to 3077. The principal point also increased into 2040. The radial distortion also increased to 0.1472. This is the extrinsic vectors. That's all from me. Thank you.